Okay, so we want to find the volume of the solid obtained by rotating the region enclosed by y equals x, y equals square root of x, about y equals to 1. Okay, so let's draw a picture first. Let's say I've got my axis here, and then I'm going to draw y equals to x, and I'll draw this part dotted because it's not going to intersect there. And then I'm going to draw, so this is y equals to x. And then y equals to square root of x. Okay, so what I'm rotating is this stuff right here. And I'm going to rotate it about y equals to 1. So 1 is actually the intersection point right here. So this is where I'm going to rotate y equals to 1. Okay, so since I'm rotating right here, remember what you want to do is make a mirror image of these on the other side of your rotation. So I'm going to do that. So that's a mirror image of this guy. And then I'm going to do the same thing for my line. Whoops. Sorry about that. My line y equals x is going to get mirrored over on this side. Okay, so then I'm going to draw a washer because that's the shape that I end up with. So if I rotate this guy, I'm going to end up with a washer that looks kind of like that. So let me just blow this up over here. So this is my washer. And so let me just kind of fill this in. So that's what this guy looks like. And so what I want to do is to find the area of the cross section. The area of the cross section is equal to, it's just going to equal to pi times the big radius. So the radius, the distance from the center to the outside. So the big radius squared minus the small radius squared. So the distance from here to, I'm just going to draw it to there. So that's going to be little r. Okay, so that's my strategy. So I need to find what those guys are. So if you take a look from the center to the outside edge, I need to find what that distance is. So it's actually easier to look at it from here to the axis, because basically, so right now I'm finding big R. So notice that from this line, your axis, to the x-axis, that's a distance of 1, because that's the line y equals 1. And then, but to find the distance from here to here, this red line that I just now drew, that distance is going to be 1, but you're going to take away this distance from here to here, which is your y value. So the radius then is just going to be 1 minus take away y. Or, in this case, this line, remember we are going to integrate with respect to x because we're moving in this direction. So it's going to be 1 minus y, which in this case is equal to x. Okay, now for the small radius, the same exact idea. It's still going to be from here to here is 1, and then you're going to take away the distance from here to here, which is going to equal to y, or in this case, square root of x. So little r is going to be 1 minus the square root of x. And so then you plug these guys into here, and what you get is that your area of your cross section is equal to pi times r squared, so 1 minus x squared minus 1 minus square root of x squared. And so we're going to want to simplify this guy. So this is going to be 1 minus 2x plus x squared minus 1 plus 2 root x plus x. Okay, and so then this is equal to pi times minus 2x minus x, that's minus 3x, plus x squared, and then plus 2 root x. So then the volume is simply equal to the integral from 0 to the intersection, which is 1, so from 0 to 1, of the area of the cross section, which is this guy right here. Let me just put them in order. X squared minus 3x plus 2 root x with respect to x. And so if you use the fundamental theorem of calculus on this guy and all that kind of good stuff, you would get pi over 6.